All right, so homework for today. I gave you kind of the starting point that I think I left some errors in there, right? Is to finish building our rooms and connect them together with these exits. Um, so I've done it with the first couple of rooms where we built our 6 rooms here. We've built a couple of players. I'm only using one of them though. We go ahead and put that player into the very first room. So if we're going off of our picture here, this would be this guy right here. That's the entrance to our dungeon. Um, and so they get put into that room. Then to R1, we add an exit to the north leading to R2. From R1, there's an exit to the north leading to R2. From R2, there should be an exit to the south leading back to R1, as well as an exit to the north leading to R3. R2, exit to the north, R3, exit to the south, R1, so on and so forth. All right. So let's build the rest of those connections and then we'll go in and look at what our exit should look like. All right. So I'm going to just steal. Let's do this. I'm going to cut that out, cut that out, cut that out, and we'll use that as our starting point. All right, so our next room here will have R3, which goes to the south to R2. R3, south, R2. Next one is R3, west to R4. R3, west, R4. Oh, and by the way, at the end of last class, somebody else had asked, is this the way you would usually do is hard code all this stuff? Probably not. You would store your map maybe in something called a JSON file, which we'll be looking at some point here reasonably soon, where maybe some dungeon designer would create your map and then you'd have a program that reads in from that file and automatically does all this through loops and things like that. But behind the scenes, this is effectively what's happening. We're just not having to manually type all it in, but we're manually doing it for our 6 rooms. All right, so R3 to the west to R4, R3 west to R4, now R3 north to R6, R3 north, R6, R3 east to R5, R4 east to R3, R5 west to R3, R6 south to R3. All right. That cover all the deals? Okay. So now we've connected all the dots. All right. Let's go figure out what this means now. Okay. So then we want to make each room display itself showing something like this. So the room has its name. It shows who else is in that room. And then what are the obvious exits of that room? Good. Well, the code up here, nothing is displaying yet. I mean, we've just connected stuff behind the scenes. We've connected them together, but we're not actually showing anything yet. Oh, up here there was. Yeah, for that was from last time in the room constructor. So every time we initially create the rooms, we told them to display themselves. But yeah, we're going to be updating the display function. But as far as what we just wrote, nothing about that is displaying anything yet, anything new yet. But we will be updating our display function. And that's kind of what's coming here next, where our display function for our room should now show the name of the room, anybody who's currently in the room, which for our current example, only room 1 should have anybody in it, and also the obvious exits for each room, which is going to be, depending on the room, there'll be an obvious exit to the north here, an obvious exit to the north and south here, an obvious exit to the north, south, east, and west here, to the east here, to the south here, to the west here. All right, so we can kind of see that all these things occurred. All right, so let's go and look at what add exit does for right now. So when we tell a room to add an exit in a certain direction, linking it to another room, here's add exit. Add exit takes in a string direction, and it takes the room that it leads to. We do a little error checking to make sure you didn't try to make more than 4 directions. We're the ones writing it, so we could just choose not to do that. But technically, this would scream at us if we try to. A lot of these games might have like an up or down or a climb exit, something like that. But we're just dealing with north, south, east, west. So as long as this is, we haven't run out of possible exits for a room, we'll go ahead and create an instance of a new exit. What's an exit? An exit has a direction, which is a string, and a destination, which is the room it leads to. So let's go and look at exits here. Here's an exit. We're keeping track of 2 fields, the direction and where it leads, the room it leads to. Constructor for it takes in the string, takes in the room it leads to, sets those 2 fields. That's all an exit does currently. All right. So now we're going to go and update our display method for room to show this other stuff over and above what it's showing now. So we'll go back to room, go down to display. Right now, a room will display room followed by its name. It will also display whether or not there's a player here. So right now, if I were to, for example, let me just get rid of the rest of this stuff here. And we'll just use a couple of examples. So if I say R1.display and R2.display, so R1 we know is the room that has the player in it. R2 does not have a player in it. So based on the current implementation of display, when we call display on R1, it'll say room R1, and it'll say also here Mike. When we call it on R2, it'll say room R2, also here nobody. All right. And then what I'm going to do, just so we don't have a ton of stuff dumping out to the screen at the moment, I'm going to comment out our display function when we're generating our rooms. So that way we're only getting a display of the room once we've hooked everything up. Go ahead and run this guy. Remember, it's just showing R1 and R2 right now. So R1, also here Mike. R2, also here nobody. All right, so it's working for the names of the rooms. It's working for the player that's in the room or the absence of a player. Now we want to add to it the ability of showing the exits that are in this room. So we're going to go back to room here, and we're going to update display to also show exits. Say show obvious exits. So we'll go ahead and do a system.out.print obvious exits. All right, now we want to have a loop that goes through and shows our various exits. Now, even though we know that every room that we build technically has at least one exit in it, we can make the assumption that if there's no exits, we're going to say none, right? So we can say if. Now, how do we determine how many exits are in a room? When we built our field for keeping track of our exits, we built it to hold a maximum of 4 exits. Okay, we're using an array, and arrays have a structure. When we first create them, we have to say how many things are in there. When you get into the next course, the data structures course, we talk about things called linked lists, which allow you to start off with an empty collection and then add things to it arbitrarily. So then we could ask it how many things are actually in there. Where in this case, we're effectively buying like a shoe organizer that has 4 little cubbies in it that we could put shoes into, but we haven't put any shoes in there yet. So our current number of exits is the guy that tells us how many actual exits have we put into this room. And remember, when we added an exit, as long as we could legally add that exit, we created an instance of our exit, we added it to our collection of exits, and then we incremented the current number of exits. So we kept track of how many we added, knowing that number will never get larger than 4. All right. So we'll ask a question here. We're going to say if this dot cur number of exits is equal to 0, if there are no exits in this room, which we expect to never happen, but if it did, then we would do something like system.out.println none, something like that. Otherwise, we must have at least one exit. So if we have at least one exit, we want to go through all of our exits and have each one show us its direction, north, south, east, west. So we're going to do that with a for loop. For int I is equal to 0, I is less than this dot cur number of exits, I plus plus. Now, understand that it is this dot cur number of exits instead of this dot, what I call it, available exits. It's not this. This dot available exits dot length will always be 4, regardless of whether we put anything in there or not. We only want to go through the exits that we've actually put in there. So that's why we have that secondary variable to keep track of how many things out of the 4 have we actually put in there. All right. So then each time through, we want to print the direction of that exit. Now, as of right now, our exit has a private field named direction, but we have no way of getting at that. So the solution to that is a getter. So we'll go ahead and create a public string get direction, return this dot direction. So now we've taught exits how to return just the direction in a read-only format, right? We're not letting you change the direction to it, but you can get the direction it was coming from. So we'll go ahead and do a system.out.print. We won't kick it down a line per exit. We'll print out, north, south, east, west. And then on the very last one, we'll kick it down a line just for visual, whatever. Once we move to our game engine, we won't have to worry about this text-based output stuff anymore. So we're going to say this dot available exits at position I, at bucket I. This guy right here will boil down to an instance of exit. An instance of exits now have a function called get direction. That is in room. The top of room, we keep track of 2 variables related to our exits. One is an array that is capable of holding 4 exits. And the other one is a variable Kerr number of exits that keeps track of how many exits we actually currently have. And that number increases by 1 every time we add an exit. All right, so we'll go through all of the exits that we actually have, and for each one, we will get the instance of exit from our array, and then we will call get direction on that guy, which will get us our text-based version of north, south, east, west. Now we're going to go ahead and just concatenate on a space at the end of that guy. That way we don't have north, south, east, west all run together. But, obviously you get 0% on your homework if you ran them together. So doesn't matter, but this is probably going to look nicer for us. All right, after we've gone through all of our exits, we can go ahead and do a system.out.println. I usually will call the println just pass it the empty string, but there actually is a version of println that takes no parameters, that just kicks it down a line. If you go and look at, what is it, print stream, I think println is a system is a, just kind of going through something that I used to ask you all the time. This is the name of a class. This must be a instance field. I'm sorry, a static field in that class because it doesn't have parentheses after it, but we're referencing it using the name of the class. And then println must be a instance method in there. And when we went and looked at that, we saw that there's like 20 versions of print and println that know how to print all sorts of different stuff. So if it were me writing this, I would usually just call the one that takes a string and give it the empty string, and that'll kick it down a line. All right. So that's what we do at the end of our rooms display function now to show the obvious exits. We always print out obvious exits. If there were no exits, we say none. Otherwise, we go through all the exits, printing the direction of each one of those, followed by a space. And then after that loop, we press enter effectively. Right? So I can then say, well, here, we can just start with R1 and R2. So here's R1 that has Mike in it. There's an obvious exit to the north. Here's R2. There's nobody there. There's an obvious exit to the north as well as an exit to the south. If you want to see our R3 has the most number of exits, right? It goes through all of them. So we can say R3 dot display. And we should have north, south, east, west, or whatever order I added them. South, west, north, east for R3. All right. And you probably want to go ahead and print the rest of them out just to test to make sure you hooked all your wires up correctly. So we'll have it R4, R5, R6. We should have all our exits. So we already did R1, R2, and R3. R4, nobody there. There's an obvious exit to the east. Does that R4, exit to the east. R5, there's an exit to the west. R5, exit to the west. R6, there's an exit to the south. For each exit in the array of exits per room. So if we, for instance, R3, his collection of obvious exits or his collection of available exits is filled up with 4 exits. One that leads to the north, south, east, and west. Whereas R1, his collection of available exits, while capable of holding up to 4 exits, we've only actually put 1 in there. So that's why this guy only shows north. This guy has 2 in it, a south and a north. This guy has 4. This guy has one, this guy has one, this guy has one. So each room, oops, destroyed part of my dungeon here. Each room has its own non-static fields. So every instance of room will have its own name, its own potential player that lives in there, its own collection of available exits, and its own current number of exits to keep track of how many exits are actually there. So that means when we ask each room to display itself, each room has its own non-static method called display that knows everything there is to know about that particular room, including the exits associated with that particular room. All right, so that everything for the assignment? Okay, so I'll go ahead and save that. I'll put that link up on Slack. All right. So now what we want to do, we certainly could put some stuff in here to allow our player to walk through this thing. So maybe what we do is, let's see, what do I have up here? Arena. Let's go ahead and create a dungeon. So I haven't made that function or that class yet. So I'm going to create a class called Dungeon. Right? And this is going to be public class Dungeon. And Dungeon is going to have a collection of rooms that are going to be in the dungeon. And so let's kind of see how this goes out. So I'm going to create our public dungeon. I'm not going to have it take in any parameters. Well, we could name our dungeon. So let's call it string name. We'll keep track of a private string name for our dungeon. We'll say this dot name is equal to name. And then what I'm going to do is I'm going to take all of this stuff that we created here in driver. We'll throw it all in there for right now, just so it displays it. We'll take those out. I'm going to take it out of main and we'll throw it into our constructor for our dungeon. So every dungeon that we ever created instances of as we're writing it right now will be the same dungeon. It'll look the same. Perhaps we would read in from a JSON file or some other data source the uniqueness of a dungeon at some later point in time. But I've just put all that stuff here into our constructor for dungeon. So out here in driver, I'm going to go ahead and get rid of player 2 there for now. I'm going to go ahead and I'll create a dungeon. Call this the dungeon. This guy's going to equal new dungeon. What's the name of a good Death's Cross? Ooh, that's a good one. Death's Cross. That's the name of our dungeon. All right. So, just by doing this right now, even though this typically isn't the way you'd get your output, just by calling this constructor for our dungeon, it's going to do all the stuff we just did, including spit it all out to the screen. All right, so from a logic perspective, nothing has actually changed, except we're going to get a error currently, because in our dungeon, we do not have access to a variable called P1. P1 was something we defined out here in driver. So I could pass this to my dungeon. So maybe inside dungeon, we keep track of another variable. Private player, maybe the player. This guy will take in a string called the player. Say this dot the player is equal to the player. And then the player will add to room 1 is this dot the player. All right, so now we're keeping track of 2 things in our dungeon: its name and presumably the single player that lives in our dungeon. All right, and then we just toss them in room 1. So now, in order to build our dungeon, we don't just pass it a name, we also pass it the player that we're putting into that dungeon. When we run this guy now, it should show us the, oh, did I put it as string for my player? Its name, and then, my constructor's bad. It's a player called the player. All right. So nothing new there. We've just taken all the stuff we previously did in main and encapsulated it inside of the constructor for our constructor for our class dungeon. Okay. So now going back to dungeon, we've created all these individual rooms. We've also added all these exits to those rooms. We've also told our rooms to display themselves. I'm going to go ahead and get rid of that, since now we can say we're confident that we have connected all our stuff up correctly. Things looked good. All right. Now, ideally, our rooms would not just live and die in the constructor. We want to be able to have our dungeon, after we create our instance of our dungeon, persist, right? So in order to do this, we are going to have a way of storing these rooms. So we're going to introduce a new class today, mostly for convenience purposes, but it's also a good way to learn about it. So we're going to look at Java ArrayList. All right. So we see that an array list in Java is a child of something called an abstract list, which is a child of something called an abstract collection, which is a child of object. That's the hierarchy for the inheritance model. Doesn't matter. We didn't write it. We're just going to use it. But there is something here that we see this syntax right here. So I'm actually just copy this. So there's something called generics. So in the example above, the E with the angle brackets around it is a generic. Whatever we put in place of that E is the type of value this collection is capable of storing. Now, let me show you this by kind of an example. So if I code right here, I'm going to go back out to driver here. Well, player's not hurting anybody. That's actually not even displaying anything anymore. So neither of those are hurting anybody. But let me go ahead and let's create an array list and show this. Now, just going back into the documentation for ArrayList, we go down here, we see that there's the main way we would create an array list is typically the no argument constructor that just constructs an empty list with an initial capacity of 10. This is kind of our gateway drug to linked lists, if you will. So we've been talking about the idea of normal arrays as having, they're fast and they're efficient because arrays live next to each other in contiguous memory. Remember that from last term? So that means they're one memory address, one right after another. But they have the downside of what we had to do with our rooms collection of exits. where if we knew we would have at most 4 exits, we had to build our array to be the biggest size it ever could be. And then we had to keep track of what did we actually put in there. We could have avoided keeping track of what we actually put in there by just filling it with null values and just putting it in the next place where there's a null. Probably not great programming practice. So what we did is probably the correct way of going about it. But we can say that, that's really kind of inconvenient and not very memory efficient, it feels, because for most of our rooms outside of what was the R3, we were only storing a subset of the number of exits we were capable of storing. So we were wasting a tiny bit of memory in the big scheme of things. All right, unless we roll back to like the 70s and 80s when we had no RAM, and then, well, probably 60s for the amount of memory we're using here, but it's still. So it might be nice if we had a object that allowed us to store stuff like this, but didn't rely on us having to keep track ourselves how many things are actually in there. Now, an array list is based on top of an array. Whereas there's another class in here called linked lists, which you'll see in 300, you will learn how to write linked lists first, not being allowed to use the built-in class. Then we let you use the built-in class after you understand how they work. They're not hard. In fact, in some ways, we're kind of creating a linked list in here. I'll bring that to your attention when we kind of hit that point. But an array list effectively does what we did with our collection of exits in room. It just does it for us. So this guy is still based on top of a normal traditional array, and it keeps track under the hood of how many things we've put in there. So that's why when you look at this initial no argument constructor, it just says, okay, look, if you don't tell me anything different, I'm just going to build under the hood an array capable of holding 10 of these guys, whatever the generic described. So it could be 10 strings. By default, it's 10 objects, 10 generic objects. And then as you add things to it, we will internally keep track of how many things you've actually put in here. And if you run out of space, we will make it bigger. But making an array bigger means you have to go and build new memory somewhere, copy everything from the old array over, and then expand it. I'm guessing the default is it expands it by 10 each time. You could also say, look, I know I'm going to have at least 100 things in here. So let's save everybody some time. And why don't we go ahead and set the initial capacity to 110, something like that. Just a little bit beyond where is the number of things you're definitely going to have in there. Realistically, I would say the most common use is just say, look, Java, you deal with it. I don't care if it's inefficient. We won't notice. So what we're going to do here is I'm going to go ahead and build an array list. One second, just get this. Oh, sorry. So remember, if I scroll way up here, array list lives inside of a library called java.util. Have we used anything else from java.util before? What have we used? Random class. So inside of java.util, there's a whole bunch of like utility classes. All right. So because we are using array list from there, we do need to let our program, dump that guy, know that we're going to import java.util. If we want to go lazy route, we just say, look, give me everything from java.util. So that says import java.util.star, give me all of it, even though right now we're using one thing from in there. Good programming practice would be to say, just give me the array list from java.util. When you work with traditional IDEs, development environments, not using the stupid web-based stuff, I say stupid. I use this professionally fairly often for a lot of things, unless I'm doing something that I'm going to be working on across like multiple days. But if it's something I'm just sitting down to work on for an hour, I have a lot of stuff just built in here. So it's not junk. It just doesn't do a ton of the heavy lifting for you. So typically, if you're using like a popular Java IDE is something called Eclipse. If you go to eclipse.org, that's this guy. It has the Eclipse for a whole bunch of different languages, but Java was kind of the original. Um, this was originally an IBM product. I don't know who owns it now. I think it went open source at some point, but in any case, um, and actually, if anybody has ever followed writing .NET, so Microsoft.NET code, but for Mac, see, Microsoft's just as Java, the features of Java is that it's platform independent, meaning, you write your Java program once, it'll run on any computer as long as a Java virtual machine exists for it, which is Mac, Linux, Windows, cell phones, yada, yada, yada. Microsoft would say, oh, the same thing's true of C Sharp. We're going to be going into C Sharp relatively soon when we get into Unity. Microsoft would say, oh, C Sharp, uh, it'll run on any platform that supports the .NET component architecture, which is effectively saying the same thing as the Java virtual machine. The problem is that the only platform that supports the .NET component architecture is Windows. So the reality is when Microsoft said that C Sharp is platform independent, it really says C Sharp will run on any platform whatsoever as long as it's Windows. It's kind of fun. I maybe at some point told you the story where I was at the conference many moons ago when Microsoft first announced C Sharp. This was after the lawsuit between Sun Microsystems and Microsoft. Sun Microsystems sued Microsoft for stealing Java. Microsoft then created their brand new language, C Sharp, which is same as Java, just doesn't use the identical syntax. And in some ways, it's actually better now. So we benefited as programmers. But that was one of the things they were bragging about at the thing is how, oh, just like Java, it's platform independent. It'll run on anything it supports. Back then, .NET didn't exist yet. It was their predecessor to that, but it got some chuckles out of the crowd. But everybody went to that thing because when you go to other events at the conference, the vendors were handing out, bouncy balls, merch. Microsoft was handing out copies of Visual Studio 6.0, which is like a $600 software back then. I mean, all of us had already pirated it. Don't do that. Disclaimer. But so most of us went and sold it on eBay, and eBay was like 2 weeks old at the time. This is, like I said, a couple minutes ago. But in any case, as I get off topic, Eclipse is a pretty common integrated development environment for Java. So when you're using this editor and you start using ArrayLists, so like when I first typed in ArrayList here, down here, it would have automatically imported it for you up top. So it kind of manages a lot of that stuff for you so you don't have to. But for us, we want to appreciate that. So we saw in the documentation that ArrayList lives inside of java.util. So if I'm going to use it inside my program, I have to let Java know I intend to use that inside here. So I can say ArrayList, AR is equal to a new ArrayList, like that. And then if I say AR dot add, I think it's just add. Yeah. So AR dot add. There's your evidence that I work in IDEs most of the time because I keep wanting to switch back to another program instead of a different tab. I can say AR.add P1. The add function here for AR, because I did not build this using generics, assumes that what you're storing is anything that is an object. So with this in mind, I can put P1 in there. I can say AR.add the dungeon. I can just start putting random stuff in here, which actually sometimes is beneficial. I'll actually show you that here in a second as we just kind of go down this. But typically, we would not fill an array list this way. Typically, we would define our array list to hold a specific type of value. But let me just show you this example here. So I'm going to say for int I is equal to 0, I is less than, what is it, AR.size, I think. I plus plus. And what I'll do is I'll do a system dot out dot println AR dot get. Ooh, it is get, isn't it? Yeah, get edit index. And notice here, it returns a type called E. We're seeing generics at work here. So if I don't specifically say what kind of value this guy's returning, it defaults to object. So I'm going to say, get me the value at bucket I. So that will be whatever object lives at bucket I. We know the very first thing is going to be our player. The very second thing will be our dungeon. Doesn't make a ton of sense to store that kind of stuff, but we are. Now I'm going to show you a, let's see. Well, here, I'll just print it out for now. We'll see the memory addressy looking thing, but we'll see that it's two different kinds of animals. So I'm going through my entire array list. And from our perspective, it's just a fancy array. It's an array that does some of the work for us under the hood. All right. So I'm going through that entire array list. Instead of the length of the array, it's the size of the array. It's going to return 2 in this case because it's doing that work for us behind the scenes. But we see that for bucket 0, it gave us the address of a player. Bucket 1, it gave us the address of a dungeon. Everything's happy. Now, if I had built my array list differently, and I said, I want my array list to hold players. Now what you're doing is you're saying, I specifically am building this guy to hold player objects in it. Well, first of all, if I run it right now, we're going to get some screaming because it's not going to like me trying to shove a dungeon into something that's supposed to hold players. Dungeons can't be converted to players. All right. Fairly predictable. This is probably how you would usually use it. Most of the time when you're creating arrays, you would probably be storing a single type of value. But let's just assume that you did want to store more than one kind of value. Where this would be most common is maybe if we're storing players and we have those subtypes of players like warriors and mages or wizards, whatever we call them. Maybe we want to store anything that is a player, but that will include mages and or wizards and warriors or whatever we call it. So that might be a real life example of when we want to store a couple of different types of objects, but they would usually be related objects. But if I don't use this generic syntax, when we say ar.get here, this will come out as a generic object, which means if I then want to call functions on that guy, so for example, players have an isDead function. Okay. Dungeons do not, right? So if I wanted to call isDead on this, if it was a player, I could do something like if ar.get bucket I instance of player. So this is a Boolean expression that allows us to say, is something an instance of a specific class? All right, so we know there's two things in here. We know there's a player and there's a dungeon. As I spin through here, if the thing I'm currently looking at is an instance of a player, then I know I can call is dead. Make some sense? When I run this, it tells us cannot find the symbol is dead. Why? Because AR.getAtBucketEye, even though we know it's actually a player, it came out as an object because we did not use generics. Which means if I want it to be treated as a player, I have to typecast it to player. I have to say, get me that value. Yes, I know you think it's an object, but trust me, it's a player. Players have and is dead. Make some sense? This player is not dead because nobody hit him. He's just in a room by himself. All right. Now, as I mentioned, most of the time when you are using array lists, you will be storing a collection of things like players, all players. If that was the case, and I'm going to go ahead and not add that dungeon because we've seen the error that comes from that, but we want to store specifically players in here. Now, we can still ask the question if this is an instance of a player, but that's going to be a waste of time since we know it's players. I'll go ahead and get rid of that. But now, since I used the generic syntax to say my array list specifically holds players, when I get something, it will come out as a player. I don't have to cast it to be a player because we knew it was a player. Java didn't know what it actually was. So now, because I'm storing generic players, it'll come out as a player. Players have and is dead. All right. Make some sense? We are going to have homework. All right. So I'll verbally explain the homework, but I'm going to give you a starting point as usual. So we did do this, I think, at the end of last semester where we read in some input from the user using the scanner, but I'll give you the starting point for scanner. What we want to do is effectively create a prompt that asks the user, what would you like to do? We're going to put him in room one, right? Room one says there's an exit to the north. And we want to allow our player to walk through the dungeon. So we ask them, what do you want to do? They type north. It will then take the player from room one and put it into room two, showing room two. Then we'll ask the player again, what do you want to do? Well, I want to go back to the south, back to room one. North, north, west, east. So you can make your player walk through our dungeon by removing him from one room, putting him into another room, asking the user for input each time. All right. So I'm going to give you a starting point with our scanner, and then you'll have to really, most of the homework is going to be about figuring out how to remove a player from a room, putting them into the next room, and then having that room display on the screen. Okay. A hint for this will be, it will be advantageous for you to teach your players to know what room they're currently in. So not only does the room know what player, or if there's a player in it, maybe your player also knows about the room they're in. That would be very handy when you need to display to the player the current room they're in's details. Make sense? All right. So I'll give you some code to start with. I'll put that up probably here in the next hour or so. But that's going to be our homework for Monday. Questions, comments, concerns, bribes. Yeah, bribe. It probably, but you can get away without using it. It's not focused on array lists. I've effectively now you have two different ways of storing stuff. You can put it in an array, you can put it in an array list. but that's not going to be a function or not going to be a focus of the assignment. Store your room somewhere is the idea. All right. I will see everybody on Monday. Take care.